Welcome to the USA Gymnastics University. I'm Tom Forster, presenting the Gymnastics Laws of Motion Introduction for Coaches on behalf of USA Gymnastics. Now, before I start talking about the laws of motion, I wanted to first cover the three most influential factors affecting gymnastics. And those predominantly are gravity, centrifugal force, and absorption. And though these factors are dictated by the three laws of motion, they're not really laws of motion in themselves. The first law of motion that Isaac Newton created or described for us in the 1600s is an object in motion stays in that motion until it is affected by another force. The forces predominantly affecting gymnasts is gravity and a little bit of friction. The second law of motion is the greater an object weighs, the greater the force it takes to move it. And the third law is for every action an object makes, there is an equal and opposite action. But I want to first start by describing the effect of gravity that it plays in our sport. And gravity is an invisible force that draws all objects downward to the earth. We all know that what goes up must come down. In this video clip, you're going to simply see this girl drops the ball, and so it goes downward. The invisible force is directly proportional to the weight of the object. Obviously, the ball doesn't weigh very much, so it's pretty simple for it to fall. It's not going to fall very fast. However, in our sport, let's use this example. A person weighing 110 pounds is being pulled down to earth with greater force than a person weighing 90 pounds. Therefore, the heavier the object attempting to go up, the more force is required to accomplish this. So let's consider our two gymnasts. One weighs 110 pounds, we'll call that gymnast Gymnast A, and the other weighs 90 pounds, Gymnast B. For this example, we want both these gymnasts to jump up 20 inches from the ground. We know that gravity is pulling all objects downward with the exact force needed to keep that object on the ground. Therefore, Gymnast A must exert more downward force than Gymnast B, even though they're both jumping the same distance. This is why, coaches, strength is so important, because when movement requires an athlete to defy gravity, such as it does in gymnastics, the athlete that is stronger for their body weight can go higher. So the next force I want to talk about is centrifugal force. Centrifugal force is the invisible force that pulls all spinning objects outward. You've been on a merry-go-round, hopefully, where you feel that centrifugal force against your body when the merry-go-round is spinning. The factors affecting this force are the speed of the rotation, in other words, how fast is the merry-go-round going, the weight of the object, and the distance from the center of gravity. So in this slide, I've diagrammed a merry-go-round, and it's spinning counterclockwise around the axis. And for this example, I have three people standing in a merry-go-round. Person A is standing farthest from the axis, and C is standing closest to the axis, and B is standing halfway in between. Which person is feeling the effects of the spinning the most? Person A, B, or C? A. The person standing in the A position is farthest from the axis. They are feeling the effects of centrifugal force the most. The greater the distance from the axis, the greater the centrifugal force is felt whenever any object is spinning. I'm going to use this demonstration to show the effects of spinning around a vertical axis. In this case, this girl is hanging on a ring, and she starts with her legs outward, then pulls them inward. And you can see as she brings her legs in closer to the center of the axis, she spins faster. If she relaxes and her legs go out, she goes slower. So twisting around the vertical axis, the closer the gymnast can pull into the axis, the faster they twist. If the gymnast relaxes, they slow down. Whenever you've taught gymnasts how to twist in their flip, I'm sure you've experienced this. So as a coach, you need to understand that centrifugal force can be a stronger force than gravity itself. You've probably done this experiment in school where you put water in a bucket and you swung it over your head in a circle. The water is being pulled outward from the center of rotation, but the bucket keeps it from coming out. If you swing the bucket fast enough, the centrifugal force is greater than the gravitational force, so the water does not fall down.